Rational versus irrational solutions. In this video, you'll learn to determine if a solution will be rational or irrational when adding and multiplying both types of numbers. Rational numbers are numbers that can be written as a fraction. So any fraction like 3/4 is considered rational. All integer values like 2 are also considered rational because we can always put them over 1 to make it a fraction. Decimals that don't repeat, like 0.9, are considered rational as well because we can always make it a fraction based on the place value in our decimal. Irrational numbers are numbers that cannot be written as a fraction, like the value of pi, since this goes on forever, or the square root of a non-perfect square, like radical 2, or decimals that go on forever, like 0.8 repeating. Since we don't know when the place value ends, we can't make it a fraction. If we add both types of numbers together, then we'll get an irrational sum as a result. And if we multiply both types of numbers, we'll also get an irrational product. If our numbers are both rational, though, then we'll get a rational answer as a sum. And if we multiply two rational numbers, the product will be rational as well. So here are some numbers, and we'll decide if they're rational or irrational. Let's start with 97. All integers are considered rational because we can always put it over 1. Now let's look at negative 8.2. As long as the decimal is not repeating, we can put it as a fraction over the place value it represents, so this is rational. Now let's look at the square root of 5. Since 5 is not a perfect square, this is irrational. Now we have negative 3/7. All fractions are considered rational because that's what the definition of a rational number is. And now we have the square root of 100. Since 100 is a perfect square and can be simplified to positive and negative 10, this is a rational number. Here's an example where we'll find the solutions to each equation and then we'll explain if those solutions are rational or irrational. Let's start with x squared minus 8 equals 0. We'll begin by adding 8 to both sides so that we can get the x squared term by itself. This gives us x squared is equal to 8. Now we'll take the square root of each side. So we get x is equal to positive and negative radical 8. Since 8 is not a perfect square, this will be considered an irrational solution. In our next equation, we'll start by taking the square root of each side. This gives us x minus 5 is equal to positive and negative 1. Now we can set up our two equations where 1 is equal to the positive 1 and 1 is equal to negative 1. We'll solve by adding 5 to both sides. This gives us x is equal to 6. We'll add 5 again to both sides, and this gives us x equals 4. Since 6 and 4 are integers, these are both rational solutions. Now let's look at our last equation. We'll start by adding that 5 so we can get the squared term by itself. This gives us x over 4 squared is equal to 5. Now we'll take the square root of each side. So we get x over 4 is equal to positive and negative radical 5. We'll multiply by the denominator of 4 so we can get x by itself. So we get x is equal to positive and negative 4 times radical 5. So 4 is an integer, so this is rational. But radical 5 is a non-perfect square, so this is irrational. So if we multiply the two together, we'll get irrational solutions for this one. In this example, we're going to determine if each product or sum produces a rational or irrational solution. Let's start with 2 plus radical 3. 2 is an integer, so this is rational. But the square root of 3 is not a perfect square, so this is irrational. When we add the two types of numbers together, we get an irrational answer as the sum. Now let's look at 1/3 times negative 8. 1/3 is a rational number, and negative 8 is also rational. So if we multiply those together, the answer will be rational as well. Now let's look at radical 2 plus radical 3. 2 is not a perfect square, so this is irrational. 3 is also not a perfect square, so it's irrational as well. So if we add two irrational numbers, then our solution is irrational. Now let's look at our last one. The square root of 16 is a perfect square, and we can simplify this to positive and negative 4. So 4 is a rational number, and 5 is rational as well. So if we add two rational numbers together, we get a rational answer as a result. In this example, we're going to decide which of the following are rational numbers. Let's start by identifying any fractions we have, since all fractions are considered rational. The only fraction we have is 4/5, so we'll mark this off as rational. Now let's look at integers. All integers are considered rational because we can always put it over 1. So we can see that the integers of 10 and negative 3 are marked off as rational. Now let's look at the square root of perfect squares, since those are considered rational as well. The square root of 4 is a perfect square, so this is rational. And the square root of 25 over 4 is also a perfect square, since 25 is 5 squared and 4 is 2 squared. The only numbers that aren't rational are the square root of 10 and the square root of 0.6. Now we have the solutions to some quadratic equations. Which of the following produce rational solutions? Let's start by looking at 5 plus or minus 2. Since both numbers are rational, the answer is going to be rational as well. Now let's look at the square root of 4 plus 1. Since 4 is a perfect square, then it's considered rational. And since 1 is also a rational number, then adding them together will give us a rational solution. Now let's look at 1/2 plus or minus 3. Both numbers are rational, so we'll have a rational solution as a result. Now we'll go up to 10 plus or minus radical 3. Since 3 is not a perfect square, then it's not rational, so it won't produce a rational result. Now let's look at plus or minus radical 25. 25 is a perfect square, so this is rational. Now let's look at our last expression of 1 plus or minus radical 2. 2 is not a perfect square, so this is not going to give us a rational solution. In our last example, we have a graph of the equation y equals 81 times x minus 3 squared minus 4. We want to know what are the solutions. We can find the solution by looking at the x-intercepts. So it says it has solutions at 2.778 and 3.222. The only issue with finding solutions in a graph is that we don't know if they were rounded or if they were rational or irrational. So we're going to find the exact solutions to see if those are what the solutions were or if they were rounded down. Let's take the equation they gave us and we'll try to use the square root method. So we'll try to get x minus 3 squared isolated first. We know that y will become 0 since that's when the x-intercepts will happen. Let's start by adding 4 to both sides of the equation. This gives us 4 is equal to 81 times x minus 3 squared. Now we'll divide by that 81 so we can get the parenthesis by itself. So we get 4 over 81 is equal to x minus 3 squared. We'll move this up so we can have more room to solve. Now we'll take the square root of each side. So we get plus or minus 2 over 9 is equal to x minus 3. And now we can set up our two equations. So to solve, we'll start by adding 3 to both sides. So we get x is equal to 2 nines plus 3. Now we'll add 3 to our other equation, and we get x is equal to negative 2 nines plus 3. Since both of our solutions have two rational numbers included that we're adding, these are rational solutions, so it was safe to use the graph that they gave us. Let's summarize what we've learned. Rational numbers can be written as positive or negative fractions. All other numbers are considered irrational. When solving quadratic equations by graphing, it can be hard to determine if the solutions are rational or irrational. Solving with another method should be done to verify the type of solution.